Okay, good morning everyone. So,
Good morning, sir.
Good morning, sir.
good morning. We have 22 so far. Okay, so, so anybody from second year here?
Yes, sir.
Okay, Shubhanshu Ranjan. Who else? I mean, is it okay? So, how do we do this now? I mean, I understand that you are going to complete your this semester, spring semester, very shortly, and from 4th April onwards, uh, there isn't. I mean, online sessions are going to stop completely. So the lectures and all practicals they would be in physical mode. So how will you address this? Have you discussed this with Professor Chani or Arindam?
Yes, sir.
So what is the what do they say? Okay, but why are they asking for permission to join? I think if they join the link classroom, then they should be anyway allowed to join this meet session. Probably some of you have not really joined the classroom for this course. So I would request all of you to please join the classroom, and then you don't need this permission to join this meet session. So please, second year students, please sort out the confusion, and there is some confusion regarding the timetable also. The slots for this course in second year time schedule is different from the slots for this course in first year timetable.
So, sir,
Hopefully,
that's the sorted, but after ET, many students are going back to home or for internship, then we have a problem that the classes are offline and we are not in the campus, then how we can
yeah,
attend that.
so I mean that is something I cannot help you with. So you need to figure it out with your department and the Dean Academic Affairs. So, nevertheless, let's start discussing. Let's get started with the course. So, do any one of you, or how many of you have prior experience of computer programming? Yes, Abhay, please. Okay,
So regarding the timetable,
yeah.
we have like the second year have managed their slots and they have said that we have to follow the first year's timetable for AR Manmanju.
The time slot, time schedule that is given for first year that is to be followed.
Yes, sir.
Yes, sir. I have sorted that and talked with the professor and shifted to the other times we are free.
So you mean 9 o'clock lecture and 2 p.m. Practical, that session, that one?
No, sir. 9 to 11 practical and 2 p.m. lecture.
Okay, 9 to 11 practical and 2 p.m. lecture. And, ठीक है. Ah, that is something that I had rejected. I mean that those times are not convenient for me. Okay, anyway, we'll sort it out. So, did you get this information from Arindam today? Did you talk with Arindam Biswas?
No, sir. Shubham sir told me.
Okay. Okay, fine. I'll sort it out with Arindam. Let us see what happens. So coming back to this course, how many of you have prior exposure to computer programming? Nobody? That's amazing. And I guess somebody must have taken computer course in your 11th and 12th. Hmm, that's interesting. So, nevertheless, how many of you are in possession of a computer? I mean, have access to a computer, desktop, laptop. Okay. So, oh, that's okay. Fine, good, sizable number. So, how long have you been using this computer?
4 months.
Last
Okay, 4 months, and what do you use it for? For these lecture sessions and things like that.
Yes.
Okay. So, uh, has it ever occurred to you, or you must have come across several memes floating around, the how computer technology has changed and how about 1 megabyte of storage used to weigh around 2 tons, and it was ferried by a chartered plane from one location to another location for some work of IBM, right, in 1960s. So coming from that time, things have really changed a lot in computer technology, and I just want you to appreciate the fact that the cellular phone that you carry in your pockets is more powerful than the computer which was used to plan and design Apollo mission to moon. Right. So let this sink in. The what you have at your disposal is a very powerful tool, and it is capable of achieving magnificent goals, things, provided you harness its potential correctly. Yes, Aditya? Oh, okay, fine. So, did you have a chance to go through the links that I shared on the classroom page? Can you count on your computer? Okay, let me. Okay, this is interesting. I am the host and yet I am unable to share the screen. That's interesting. Okay, I'll figure it out later what is happening here about the screen share. But let us try to figure out uh, how do you make a computer work? What is the basic idea? Uh, do you have any idea about how does the computer do what you ask it to do? Anyone? You have been using computers for a long time. I mean, even your cellular phone is a computer, technically. So, any ideas? I mean, you don't have to be very precise. You don't have to be. I mean, this is
Well,
not being graded.
it takes an input, processes it, and gives an output.
Yes, it takes an input, processes it, and gives an output. Fine. That is probably very much applicable to almost everything in this world, isn't it? Everything takes in something and gives out something,
Yes, sir.
right? So, what is special about the computer? I mean, you are right in the sense that that is how any engineering system is designed. Every system is designed to take some input process it, and then do some processing and then produce some output. So that processing is what differentiates different systems. But essential block diagram representation of everything in this world is same. You have an output coming, there is a processing block, and you have some output going, right?
It does in binary form.
It does in binary. Okay, fine.
So it works on various algorithms.
It works on which algorithm?
Various algorithms.
Various algorithms. Okay. Yeah, fine. Okay, so let me take notes. What are you saying? So input output, then it is in binary mode, and then various algorithms. Fine. Anything else?
So also like it can only take logical and mathematical operations. It can only do.
Logical and mathematical operations. Okay, that's an interesting uh, input. Do you have a calculator with you right now? Calculator is also a computer, isn't it? And you just mentioned about logical computers being able to perform logical mathematical operations. So just as an aside, you have something called random number generators that is available on your calculator. Calculators would generate random numbers, uniformly distributed random numbers between 0 and 1.
Sir, I think like it's not truly random. Like for truly random, we need something physical that is random. It's
Yes,
pseudo random, I guess.
it is pseudo random. That's what. So that's what I was coming to. I mean, if it is logical, how is it that you can generate a random number by going through a set of logical steps? I mean, anything logical has to be repeatable. And if something is repeatable, then how can it be random? Right? So that's a kind of contradiction there. But you got it right. It is pseudo random. It looks to be random, but in practice, it is just a set of numbers uh, which repeat themselves after some period. Right. So period is that range of numbers in the. So if the range of numbers is very large, then practically you can consider that as a random number for your computations. But if you let that random number generator run for a sufficiently long time, you will find that the pattern being repeated. So that's a logical step, and that is a repeatable sequence. But for a short enough duration or short enough segment of that series, those numbers do appear to be random, and they serve the purpose of random Monte Carlo simulations for many applications which require random input. So that is that. Uh, so you may be aware that current age is referred to as information age. Right? The current age that we live in is the information age. You right? What was the previous age?
Industrial age.
Industrial age. So industrial age was characterized by machines, right? So what is a machine? I guess all of you must have watched Three Idiots, and
Yes, yes, sir.
don't quote that. Actually, I phrased this question much before Three Idiots came out. So, what is a machine? What do you think a machine is?
A machine is anything that reduces human effort.
Reduces human effort. Actually, uh, what I'm looking for, or what I was looking for, is more general concept which was very crucial, central to the industrial revolution. So machine, any machine is essentially energy transformation device. You take input energy in some form and the output is some transformation of the input energy. Right? So your internal combustion engines, you take chemical engine, chemical power, the fuel, and then convert it into mechanical power, mechanical energy. That is one sort of machine. Levers are another sort of machines. That's purely mechanical power from either side, but they allow you to do some work. Right. So all machines that you see, you will find they always involve some form of uh, energy transformation. So next age, beyond industrial, after industrial age, industrial revolution, we arrived at information revolution. So information revolution is central. The computer is central to this information revolution age. And a computer is a machine which transforms information. So you have information input in some form, and then the computer processes that information in some way. That is what these algorithms are. What you somebody mentioned about the computers using algorithms. So those algorithms are what the processing is encoding of processing that needs to be done, how the input information is to be processed. So that is a sequence of operations. That is what algorithm is. And after you are done with this, you get the output, that is the processed information. So it's another input-output system. So you have input, you process that input, and you produce an output. But the difference here is the input is information and the output is also an information in some form. Right? So that is the basic concept of a computer, and that holds, for all computers. So where does that take us with regard to the programming of computers? What do you do? What do you mean by programming the computer, and how does the computer understand what you are commanding it to do? Right? So there are different programming languages, and somebody said binary mode. Computers were not always designed to work with binary numbers. Binary is, I would say, is of relatively recent vintage. binary representation became a standard as late as 1980s. Until then, it was complete chaos. Different manufacturers had their own number system for representation. Hexadecimal was by far the most popular number system for computers. Any guesses why hexadecimal was popular? In fact, uh, one Russian computer had base 32 number system. It was designed on base 32 numbers. Right. So, why this? Why these large base numbers were preferred earlier and they were discarded, definitely discarded after 1980s, late 80s. Any guesses? See, earlier the storage was very expensive. Computer storage was very expensive, and therefore engineers were looking for ways to encode as much information in as small storage as possible. So a hexadecimal number, it has 16 states, right, ranging from 0 to 16, 0 to 15. Right, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A, B, C, D, E, F. So these are the 16 different states. So the point is, one word length allowed you to encode 16 different configurations. So the space requirement to encode information was smaller. I mean, it will be smaller the larger the base number system is. So for 32 base 32 number, you have 32 possible states. So one word length can actually encode 32 different configurations, and those configurations can be encoded using some standard transformation to mean different things. So information encoding gets very compact if you keep on increasing the base of the number system. So very good. So why was this abandoned? This seems to be very good kind of arrangement, very economical, very efficient. The problem is design of circuitry to distinguish between these 16 different states was challenging. And that was the reason why old days computers were not very reliable. Right? Imagine, in order to, all that you need to do, all that you can do in a circuit is measure the voltage. Either measure the voltage or the current running in a circuit, flowing through a circuit. So you need to make a differentiation of these 16 levels for base 16 hexadecimal numbers, or 32 levels for base 32 numbers. And there can be, I mean, if there is a glitch, and in those times computers were still built using mechanical relays and contact relays, copper contact relays. So different positions of those dip switches would indicate different levels, and those were all based on electrical contacts, copper contact. And actually, one of the interesting anecdote is the term bug actually arose because there was a bug between two contacts, copper contact, and although physically it seemed as if the relays were in correct position, but because there was a bug trapped in between these two contacts, the electrical contact was not complete, circuit was not complete, and the program, of course, misbehaved. So that is the origin of the term bugs in computer program. So the point is, large encoding resulted, although they did allow considerable saving in the storage information, storage capacity, but the offside was the resulting challenges in the design of circuitry to distinguish between these different levels was immense, and that's why old times computers, mainframe computers, would be so huge they would fill up the entire hall, and the power of that computer would be uh, even less than what you have in your cell phones today. So that's the significant technological advancement that uh, semiconductor technologies have allowed. So gradually, as the semiconductor technologies evolved and the cost of storage came down, then it was decided that it was consensus that it is very